So, for triangle similarity, we have, well, as a topic we're going to be going over today, we have three main sections that we're going to address. So now I'm going to review these three one by one. Before that, what is similarity? We have no idea. That's probably why you're clicking on this video. So first of all, triangle similarity is where you have two figures and you want to figure out if they're similar or not. And now similar basically means if you have a figure that has like sides 3, 4, 5, and then you have a figure that has sides 6, 8, 10. They're similar because they are in a ratio of 2 to 1, and that would be SSS similarity. But we'll go further on that. But similarity in general is where any figure that can be dilated from the original figure, which dilated basically means like resized, and it will still have a ratio corresponding to the original figure. So as I said, like 3, 4, 5 sides, and you basically dilate it, so you make it 2 times as bigger, then it will go to 6, 8, 10. So now, as I said, first is SSS similarity. SSS similarity is going to be what I said. So if you have sides, let's just draw it out here. So let's say you have a figure like this. Nothing is drawn to scale. So let's say it's 3, 4, 5. And then you have another figure that's a little bigger. And it's 6, 8, 10. These two figures are similar because if you take it into corresponding ratios, 6 to 3, then you have 8 to 4, and 10 to 5. So if you take all these ratios, you can all be simplified, as we know. So that's going to be simplified to 2 to 1 for all of them. You can only have SSS similarity work out if 2 to 1 is like available for all of them. Like if you have 2 to 1, 2 to 1, and let's say this was 12 to let's say this was 15 to 5, and if it goes to 3 to 1, figure is not similar to each other because the ratios do not correspond to each other, so they're not all 2 to 1. So that's basically SSS similarity, and this one is it's not, you're gonna see it quite often, so it's good to just know that basically they're gonna ask you for the corresponding thing. And later on we're gonna go ahead and see if we can basically find an unknown side based on the corresponding values. So next is AA similarity. So this is also called angle-angle similarity. So this one's side, side, side because we need to know all 3 sides. For angles, however, in a triangle, as there's 3 angles, you might think that we don't need to know all 3. That's not quite true. Actually, you only need to know 2 because if you know 2 angles, the other angle will be the same angle. So if you didn't quite understand what I just said, I'm going to just draw it out. So let's say you have this, and let's say you have another one. So let's say this has angle, I'm going to make it easy. So let's go 50 degrees, 30 degrees, 50. Let's go 100. So now you would think these are not similar because they're not you would think that these are not similar, but they actually are because if you look at the 3 angles, you can fill in the unknown angle. We all know that the triangle angle sum theorem states all 3 angles in a triangle need to equal or add up to 180 degrees. So based off of that, we know that 30 plus 50 is 80, which means this unknown angle would be 100. And same thing here, 100 plus 50 equals 150. So 30 would be the unknown angle there, and therefore the two figures are similar. Now, this is a great concept to learn, especially this and this. These are the two basic ones. SAS similarity is a little tougher, but basically angle similarity, since you know two angles, you can find out the other one, and if they all correspond, like if all the angles correspond and they all match up, you know you have two figures that have angle similarity. So, which also means their side, it would correspond to SSS, it would correspond to SAS. If you have one of these, all of these other ones would apply. It's just you don't have to know which one to apply in which scenario, because you cannot apply every single one of them. So, finally we have SAS similarity. SAS similarity is a little more difficult. It took me quite a while to understand it, but I kind of have it down. This is a major one where you really need to think about dilation and the resizing of figures, because SAS means side angle side, which basically means the angle between two sides. So you're given side length, angle, side length. So the angle between the two sides. So let's say, this is not true, but we're just going to take it for example. Let's say 5, 10, and we have angle, I don't know, 50 degrees or something, okay? This is not true, but something like this. And then same thing here, but let's say we have 20, 40, and 50 degrees. So here you might think, they're not similar because you don't know the unknown side length. You also don't know two angles. Excuse me. But that is why you have SAS similarity, because 5, 10, you have a side, and you have an angle right in between. So basically what I mean is the angle here, angles don't change. The sides, of course, SS, they can be in different ratios. Angles will always be the same. You cannot dilate angles or anything like that. Now you can dilate the shape, which is what we're doing here. If you were to make this figure larger on a dilation basis, you could end up getting 20 to 40 based on 5 to 10. So when you have 5 corresponding to 20 in a 4 to 1 ratio, and 40 corresponding to 10 in a 4 to 1 ratio, and then you have the unknown angle, or you have the angle, it's easy to tell. Even if you dilate, you know the unknown, you will know the unknown, you won't know the unknown length, but you can classify it under SAS similarity with these two. Now, why, SSA, you might think will work. It won't work because you know this angle, but you know one of these two angles. Now, that won't work because we don't know on a dilation basis what would happen. Because we don't know the angle between the two sides. So we can't tell if you resize the shape. The angle, the sides will stay the same, and the angle will also stay the same because it's unknown and we don't know. So SSA similarity does not work. Now, I'm just going to go into a few examples right here, so we're not going to, stop the video. We're just going to go right into some examples. Let's just do them. So, let's do an SSS similarity example. So, so now we have a 3, 4, 5, and 6, 8, 10. We saw that. So now I'm going to give you a little harder example. So let's say we have a figure of a little easier than that. And by the way, this would be a right triangle. I realize that, but just for now, it's not. Let's say you have 2, 6, and 8. So they have 2, 6, 8, and I'm going to give you a moment to pause the video. I'm going to fill in for you guys 6, okay, 6, and we also know 24. So now I want you guys to find the unknown length. So just take a moment to pause the video and do this right now. Okay, so hope you guys had a chance to do that. And basically, if you saw this, you already know 6 to 2, 24 to 8. You have a 3 to 1 ratio happening here. So you obviously know that with this one being the one side, this has to be multiplied by 3 in order to get the SSS similarity. So this unknown question mark would be 18. So if you guys got that right, good job. The next one is going to be AA. So AA similarity is basically, it's kind of an easy concept. This says 3, sorry. Might look confusing. But AA similarity. AA similarity is, I'll give you another example here as well. So let's see, let's say 40, 20, and you don't know that one. Let's say you don't know this, but you know these two. So what are these unknown two sides like? Now you don't, this might be more of a triangle angle sum theorem, but it's fine. So another moment to just pause the video and just see what is made out of this. So again, guys, the question mark in the first one is going to be 120 because this one corresponds here. You know the 40 here, so 120 plus the 40 is 160, making that angle 20 degrees. So if you guys got that one right, good job again. And finally, we have an SAS similarity question. And this one's a little tougher, but let's do an example. So let's say we had a 15 side length and a 3 side length, and this middle angle is actually unknown. We don't know this side length. Now we have this one. We have 30, and we have this one, 50. No, let's not do 50 again. Let's do 70 degrees. But you don't know this. So here I'm kind of giving you an SSS and an AA kind of like mixed together. Not really, but just do this one next. So hope you guys had a chance to do this one. So basically, again, this is going to be a 2 to 1, assuming that it's SAS similarity. This is a 2 to 1 ratio. So 30 to 15, which is also, of course, what I said, 2 to 1. And next is going to be this one. So the unknown question mark here, you're going to have 6, because of course this is a 2 to 1 similarity ratio. And then 70 degrees, obviously this is also going to be 70 degrees to maintain the angle. And that is going to be it for ESP reviews. Thank you guys for watching so much, and I hope you guys like this video. If you guys like this video, make sure to leave a like, subscribe to the channel, and I will see you in the next one. See ya.